Hi everyone, I'm Miley.
Hey everybody, I'm Josue, and this is our senior project presentation. Our senior project was the R744 Transcritical Educational Demonstration Unit. And we decided to focus on this project due to a common problem here in the West Coast of the United States that has affected mostly California and Nevada. In California, we have recorded our hottest years the past 5 years. Here, specifically in San Luis Obispo, 2020 was one of the hottest years on record. We had a record-breaking temperature during one of the summer days, which was around 116 Fahrenheit. So we wanted to see what we could do to help the people and the environment. So we dug deeper into seeing what other ways of collecting and producing water there was for areas with a really dry climate where there's little rainfall, but there is a really high humidity level in the environment. So the target of our project is to provide an alternative for the collection of water, which will be condensing the water from the humid air using a refrigeration cycle. This refrigeration cycle will be composed of R744, which is CO2, carbon dioxide. And the basic function of a refrigeration cycle is extracting energy from one source and rejecting it to the other source. Um, the refrigeration cycle is only composed of four basic units: the compressor, the condenser, the expansion valve, and the evaporator. On the pH diagram, we can see where each of those components goes, and we can see how the transcritical properties of CO2 can help optimize this process and why it is beneficial to use CO2.
All right, like Josue just said, we decided to use R744 as our refrigerant. This is because it's very environmentally friendly and it's also very efficient. So it's actually getting a lot of traction in industry lately, which is why we decided to use it in our project. We also decided to focus on adjustability since this is going to be an educational device. We bought an evaporator with a variable speed fan and an electronic expansion valve. Both of these are equipped with 0 to 10 volt signals so that students can change the settings in 0 to 10 volt increments. This is going to be able to help them come up with optimal settings.
So our next step after finding all the components we needed for our unit was assigning a model. We decided to use the 3D modeling tool SolidWorks to include all the parts and the components. Here we can see the compressor, the condenser, the evaporator, and the expansion valve. We were able to model the specific locations of each component and the piping layout for everything in the unit. This model was built to scale, and we can observe that with this model, we can have real-time data collection of how much water we're able to produce from the humid air.
All right, so because of COVID, we weren't actually able to build the unit ourselves, but we created detailed assembly instructions for future students. This will be a really great research project for Cal Poly's hands-on learn by doing philosophy. Our mentality in creating these was to make them sort of like building a Lego set, like Lego set instructions, because I don't think I've ever met an ME student who didn't play Legos with as a kid. So we created these drawings that have all of the parts specified. We bought all of the parts, the piping, the fittings, the components, and every single section. We chose to do sections in between every single refrigeration component. We'll tell the students exactly how many of each part they need to build and where to put the parts. All right, so looking forward, this is going to, as I just mentioned, create opportunities for freshman labs for data collection. It's also going to be able to be used for student research and future student projects for assembly and for finding optimum settings. This is just going to be a really great addition to Cal Poly's freshman labs as a learn by doing, hands-on, students are touching actual refrigeration equipment and yeah, so we'd also like future research programs to test this against less environmentally friendly refrigerants like R134A. And we honestly just hope this is going to inspire future students to use mechanical engineering ideas to help our current climate crisis. All right, thank you so much for watching our video, and I hope you guys enjoy checking out our website.